Today, we're going to go ahead and solve multi-step equations. The first thing that we're going to do is reference to our step 1. We're going to check both the left-hand side and the right-hand side of the equation to check for grouping symbols. I don't see any parentheses. What I'm going to do next is do step 2. Take a look at the left-hand side to see if I can combine any like terms. Because there are no like terms, I'm going to take a look on the right-hand side. I cannot combine anything or any of those terms there, so I'm going to move forward to step 3 and try to isolate my variable. I'm going to look for the variable term that has the least. That would be this negative 1x. What I'm going to do is go ahead and use inverse operations, and I'm going to add x to both sides. By doing that, on the right-hand side, I've just eliminated the variable. I'm going to go ahead and bring down 14, which is the same as 2. And then what I'm going to do is combine that 5x and the x. Those are like terms, so I would have 6x here. Then what I'm going to do is move on to step 4, and I'm going to isolate that 6x. Now, x is being multiplied by 6, and you also add 2 to that product. So I'm going to undo the addition first by doing the inverse operation by subtracting 2, which would give me 12 is the same as 6x. Then what I'm going to do is use the inverse operation of 6 times x, and I'm going to divide both sides by 6. In doing that, I would get a solution of x is equal to 2. In order to check my work, what I would do is substitute 2, which is the value of x, into the original equation. What I'm going to do is go ahead and substitute it in every single time I see x. I'm going to go ahead and write parentheses where that variable is, and I'll highlight that for you so you can see where I've put or substituted in that variable x. When I simplify this, the left-hand side and the right-hand side should be the same. So let's check to see how we did. 5 times 2 is 10, plus 2 is 12. And on the right-hand side, the opposite of 2 is negative 2. And if I add 14, then I get 12. And I just solved that equation, and I know it's correct because 2 is the only number that would make this equation balanced or true. Let's try another one. I'm going to encourage you to pause and write down each individual step as we go. Here it is. As we solve this one today, we're going to check for those grouping symbols in step 1. I see grouping symbols on the left-hand side right away. What I'm going to do is treat each grouping symbol separately and do the distributive property. So what I will do is do 2 groups of x and 2 groups of 3. That would give me 2x plus 6. I'm going to use multiplication here for distributive property. Then what I'm going to do is take 5 groups of x minus 2. So I'm going to do 5 times x, which is 5x, and I'm going to do 5 times negative 2, or 5 groups of negative 2, which is negative 10. I'm going to bring everything down on the left-hand side. Now, because there's no more grouping symbols, I'm going to move to step 2, and I'm going to take a look at the left and the right-hand side to check to see if I have any like terms. I see like terms on the left. I see 2x, and I see 5x. Those are both alike, and when I combine them, that would make 7x. I also see a 6 and a negative 10, and when I combine those, I would get negative 4. I'm going to set that equal to the left or the right-hand side because I know there are no like terms here, so I'm just going to rewrite it. Then what I'm going to do is move to step 3 where I'm going to start to isolate my variable. And when I do that, I'm going to take a look at which one of these terms is going to be the smallest x value. And it's right here, negative 1. So I'm going to go ahead and get rid of that negative 1x, and I'm going to add x to both sides in order to do that. This would eliminate, leaving me 10 on the right, which is the same as I'm going to bring down the negative 4, and I'm going to combine 7 and x. Remember, if I have an x here, that really means 1x. So 7x and 1x would give me 8x. Okay, I'm going to continue to isolate And I'm going to do that here by doing the inverse operation. To get that 8x by itself, I'm going to add 4 to both sides. Remember, you want to undo all your addition and subtraction first with inverse operations. By doing that, I get rid of that negative 4, which I wanted to give me 8x is equal to 14. Then what I'm going to do is use the inverse operation of multiplication to undo that, which would be division, and I'm going to divide both sides by 8. Now 8 divided by 8 is 1x, but this is a unique situation where I have a 14 and an 8. So 8 doesn't go into 14 an equal amount of times, so I could leave it as 14 over 8 as an improper fraction. If I do that, I should reduce. If not, I would go ahead and see how many times 8 goes into 14 with the remainder. I'm going to go ahead today and just reduce this fraction. So I'm going to divide 14 by 2, which would give me 7. I'm going to divide 8 by 2, which would give me 4, and I'm going to leave my final answer as 7/4. I'd like you to go ahead and pause and make sure that we can check our solution, and then let's move on to the next one. In this one, number 3, we have another unique situation where I have a 4 minus 6 with a parenthesis w plus 2 equals 10. Again, we're going to start with our step 1, and we're going to undo any distributive property or those grouping symbols. But unfortunately, 4 is not part of that symbol. I'm going to go ahead and bring that 4 down, and then I'm going to do the distributive property and multiply everything in that parenthesis by negative 6. So negative 6 times w is negative 6w. You would do negative 6 times 2, which is negative 12, and then I would bring down that 10. I'm going to look for like terms. I have a negative 12 and a 4. When I combine those together, I end up getting a negative 8. Don't forget your negative 6w and our 10. Then I'm going to go ahead and try to isolate this negative 6w. By doing that, I'm going to get rid of all my subtraction here first to isolate this variable. Remember, isolate means I'm going to put that variable all by itself. Negative 8 and positive 8 do eliminate. I'd be left with a negative 6w, and I'd be left with a 10 plus 8, which is 18. In order to do this last step, I'm going to divide both sides by negative 6 because I'm multiplying w by negative 6, so I'm going to divide by negative 6 by undoing that multiplication with the inverse. And when I solve, this makes 1, so I'd be left with w equals negative 3. We have one last one today, and it looks like this. This is another interesting scenario. As we look at this one, we're still going to break apart our left and right side, but I only see grouping symbols on my right, so I'm going to go ahead and take care of that. Now in class we talked about that there is a negative symbol in front of this parenthesis, and there really is a hidden symbol here. It means 1. So what I'm going to do is bring down that negative x, and then I'm going to multiply everything inside by negative 1. We could also think that this means that I'm going to take the opposite of everything on the inside of that parenthesis. And when I talk about opposite, opposite in sign. So negative 1 times 3x is negative 3x. Negative 1 times 3 is negative 3. I'm going to go ahead and bring down the left-hand side because I didn't see any grouping symbols. And now I'm going to start to combine like terms. I see a negative 3x and a negative x. Combining those, it would give you negative 4x and minus 3. I also see on the left a 4x and a negative 2. I'm going to combine those to get 2x plus 3. Now we're at the step where we're starting to get all of our variables on one side. I'm going to start here with a negative 4x, and I'm going to eliminate that. That's our smallest variable term. What I'm going to do is I'm going to add 4x, which is the inverse. Remember to do that to both sides. By doing that, my x's would eliminate, leaving me negative 3 on the right. I'm going to bring down the 3 on the left, and then combine that 4x and 2x to get 6x. Here, I'm almost done, so I'm going to eliminate this positive 3. by taking away 3 on both sides. I'd be left with 6x on the left and then negative 6 on my right. And because 6 is multiplied by x, what I'm going to do next is to divide by 6 so I could show that x is equal to negative 1.